Organic compounds are compounds that contain carbon atoms that are bonded to each other, and they're bonded to hydrogens. But they can also be bonded to oxygen, nitrogen, and sometimes phosphorus and sulfur also. So these are a whole class of compounds. Everything else is called an inorganic compound. And these are compounds that aren't carbon-based. So pretty much everything else. They do include a couple of compounds that contain, or ions that contain carbon, but these are inorganic. Carbonates, carbides, cyanides, carbon dioxide, and carbon monoxide are all considered to be inorganic. Now, there's a couple of terms you need to know. Molecular formula. A molecular formula you know from grade 11. And a molecular formula indicates the number and type of atoms present in a compound. For example, CH4. This tells us that in this compound there's 1 carbon, 4 hydrogens. A structural formula is actually a diagram, and it indicates the placement of bonds and atoms. So it shows the placement of bonds and atom. So for CH4, the structural formula or diagram would have 1 carbon. You put in the 4 bonds that each carbon has, and at the end of each carbon is a hydrogen atom. So there's your structural formula. There's also a condensed formula, which again is more like a diagram, and it shows the bonding order, but not the actual bonds. So for instance, if we have C3H8 for our molecular formula, a condensed structure would tell us that it's CH3, CH2, CH3. So this is the condensed formula. And what that's telling us is that the first carbon has 3 hydrogens bonded to it. It's bonded to the second carbon that has 2 hydrogens bonded to it. In turn, it's bonded to another carbon that has 3 hydrogens bonded to it. So there is your structural formula for C3H8, and then this is your condensed formula. So it shows the bonding order, but it does not show the actual bonds. Now, carbon can make covalent bonds with 4 different atoms, so it can make thousands of different molecules. Some of the molecules have the same molecular formula, but different structural formula. If this happens, then you are an isomer. An isomer is a compound with the same molecular formula, but different structural formula. Because it has a different structural formula, it's going to have a different name, and it's going to have different properties. For example, C4H10. Each carbon could be bonded. So each one of these carbons has enough bonds so that it makes 4 bonds. You put in your H's. Now, this has a structural isomer where only 3 carbons are in our longest carbon chain, but the middle carbon has another carbon coming off of it. Each carbon has 4 bonds. Put in your hydrogens and you'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This structure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they both have 4 carbons, 10 hydrogens, but they are bonded differently. And I cannot rotate around one of these carbon-carbon single bonds to get the other structure. You actually have to physically break bonds and reform bonds to go between these two. So these are called structural isomers. They're also called constitutional isomers. So some textbooks call them constitutional isomers, some call them structural isomers. Now there's another kind of isomer you can have, and that's a stereoisomer, and this will occur if you contain at least one double bond so these are if you've got a double bond between 2 carbons and each carbon in the double bond has 2 different atoms or a group of atoms. Attached. Here's 2 models. They have the same molecular formula. They are both C4H8. The black balls are the carbons. The white balls are the hydrogens. Then the gray and the purple sticks are the bonds. Don't worry about the 2 different colors. Okay, here's a carbon and here's another carbon that are on either side of a double bond. And you can see, if you look at one of the carbons, it has a hydrogen attached to it and it has a group of atoms attached to it, a carbon with 3 H's. The other carbon in the double bond has an H and also a CH3 group. Now, if you look at the lower structure, here we've got the 2 carbons involved in the double bond. This carbon has a hydrogen and this group of atoms attached to it, but the other carbon has 2 hydrogens attached to it. So the bottom structure cannot be a stereoisomer because it has a double bond, but one of the carbons does not have 2 different atoms attached to it. So this is not going to be a stereoisomer. It's just a structural isomer of the top structure. The top structure is a stereoisomer. It's showing one of them, and there's 2 possible, and we'll get to name it. So when we have a stereoisomer, we can have a diastomer or geometric isomer. And these are either going to be cis or trans. Cis or trans. To determine if it's cis or trans, you look at the double bond itself. Here's the double bond. And you look at the 2 groups that are attached. One carbon has an H and a methyl group. The other carbon has an H and a methyl group attached to it. And what you do is, if the hydrogens are on the same side, this would be called a cis isomer. And if the hydrogens are on the opposite side, so if this had the CH3 or the methyl group going up and the hydrogen going down, the hydrogens would be on opposite sides of the double bond, so that would be a trans isomer. A trans isomer. So we're going to get into naming, full naming soon, but this would be cis butene, and this would be trans butene. But we're going to get into naming soon. The other type of stereoisomer is an enantiomer. And this occurs when 2 isomers are mirror images of each other. So you have a carbon, you have to have a carbon with 4 different groups attached, or 4 different atoms attached. So no matter how you try, you cannot superimpose these 2 images. So that's an enantiomer.